Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss about a system structure known as layered approach. We know that the layered approach is applied to an operating system. What are the advantages and disadvantages of layered approach and when to apply in which operating system can be discussed in this video. With proper hardware support, an operating system can be broken into parts in smaller and more effective modules. These modules thus can be implemented while designing an operating system. The operating system can then gain more and more control over the computer and the applications that make use of the computers. This leaves the implementer the freedom of the changing inner working of the computer and thus creating a more functional modular operation system. Under a top-down approach, the functionality and all features of the operating system are determined and separated into different components. Now, these components can be used for services and routines and interrupts. Information hiding is also important because it leaves the programmer the freedom to implement the low-level routines as they see fit, provided that the outer surface of this routine stays unchanged and the routine can itself perform the advertised task. Now, to approach this layered structure, one can layer the operating system in many ways. The basic layer or the layer 0 is known as the hardware and the outermost layer is known as the user interface. Now, the operating system can lie anywhere between these layers. An operating system layer is an implementation of an object-oriented design model that includes data and the operations that can manipulate on those data. Operating system layer, say layer M, can then invoke a lower level routines and the data structure containing and service routines can be invoked by the higher level routines. So the layered structure is useful for debugging and system implementation. The way that the higher level routines can only invoke routines or services from the lower level only. So this specifies the debugging and the verification task very easier. Suppose that the basic layer is the hardware layer, so we have to debug the layer 0 without any concern for the rest of the operating system. Now as the layer 0 is debugged, so the layer 1 can be debugged with the help of this debug layer 0, as we don't have to concern for the layer 0 debugging. So if the error occurs during the debugging anywhere in the layer, then it operates only in that layer because the previous layer is always debugged. So this way designing and implementation can be simplified. Each layer can only access the routines from the lower levels, so we need not to know that how the operations are made. We only want to know that what the operations do. So the basic data structure, hardware, memory management of the higher level routines are hidden from the lower level routines. The major difficulty of doing this layered approach is that to correcting the functionality. So to correct functionally layered the system, that it basically can access the higher level routines by the lower level routines and services, the operating system must be precautiously designed. This design can help us to give us the goal to achieve the layered approach advantages. For example, a device driver for a backing store is always below the memory management layer because memory management can require the backing store often. The other requirements may not be so obvious. The CPU schedulers can be below the backing store device drivers. The CPU schedulers may be below the backing store device driver, as the CPU scheduler can schedule the CPU algorithms at a later time that the device driver is using the devices. But many times the CPU scheduler actually contains all the active processes information that needs swapping in and swapping out the memory space, so the CPU scheduler should be above the device driver backing store. In this way, layered approach can be advantageous. A final problem with the layered approach is that the layered approach tends to be less efficient than the other types. For instance, if a process executes a system call for an I/O operation, then it must execute the system call for the I/O, which in turn system calls for the memory management, which in turn system call for the CPU scheduler, and then it is only passed to the hardware. So every time the system is calling, a data method need to be passed, the parameters need to be modified, so it longers altogether system calls than to a non-layered approach. So these advantages make a backlash against this layered approach during the few years. So a more functionality in few layers is being designed where the advantages of the modular approach can be achieved and the designation and errors from the layering definition and compilation can be avoided. So in this way we can design and implement a layered approach. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.